In this video, we're going to talk about estimating large numbers. If you're watching this video, you've hopefully also watched the YouTube videos that I recommended you watch beforehand, and I just want to talk about the last one. So in that last video, they talked about estimating the amount of people that were at Trump's inauguration, and it's like, why is that important? Why is it important to know the amount of people that come to an event or that come to something like a protest? Basically, politicians want to make decisions that will please the people that live in the areas that vote for them or in general in the country. And so they need to have an accurate picture of what the people actually want. And so when we get together and we protest an issue or we get together to make a loud message about an issue, it's important that the government or whoever is reporting on that is able to get an accurate number of people there in order to say, like, how important is this issue to the people? How many people actually showed up to say that Black Lives Matter, or whatever other issue they are coming together to discuss and to make their voices heard. So by estimating large numbers, it then can have consequences in the political arena, or how lawmakers respond and what they decide to do about that issue, depending on how many people showed up. And then it can also be an indication of like popularity of presidents or current global or political circumstances and things like that. So there are lots of real world applications and consequences from estimating large numbers in situations like protests or large important political events. All right, so let's talk about how do we actually do that. If you have a copy of the handout, there's some practice math warm-up questions here I'm not going to worry about today. Let's just move on and get right into talking about large numbers. Make an educated guess. How can you determine the number of fans at a basketball game or the number of students at a dance? In many cases, the ability to estimate is more useful than the ability to calculate an exact answer. It's close enough to know that there were about 2,000 fans at the game. Estimation also works well with time. For example, a flight scheduled to depart at 10:37 and arrive at 12:46 means that you'll be in the air for a bit more than 2 hours. Rarely is it important to calculate the actual length of the flight as 2 hours and 9 minutes. And you'll notice this is just copies from a workbook from McGraw-Hill Ryerson. This is their workplace grade 12 math textbook, and we're just going to use a few pages from that to guide our learning today. All right, let's take a look at our example picture here. So we have a picture of a whole bunch of people at the beach, and we're asked to estimate the number and describe the strategy you used. The main concept behind estimating large numbers is that we're going to take our large area, we're going to slice it into chunks, and we're just going to count one chunk. So instead of having to count for the whole picture, we're going to slice this up into strips and see how many people are in each strip. And so it's kind of going to be a conversion question again. We're going to know how many strips we have, we're going to know how many people we have in each strip, and we're going to multiply and find the total number of people. All right, and in this case, I'm going to cut this into about 6 strips. So if you have a physical copy, you can follow along and try this on your own, or you can just watch and see how I do this. So I'm going to cut this in half first. It doesn't need to be exact. Everything can be approximate because the whole point here is that we are estimating. All right, so, and about here, and about here, and about here, and about here. So how many strips do we have? 1, 2, 3, 4, 5, 6. All right, let's count how many people appear in a given strip. And so I'm going to switch my little pen here, and I'm going to mark every person off after I've identified them. And I think we're okay to use this one here. Oops, let's try that again. All right, let's count how many people appear in the first strip. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And this guy's kind of like halfway on the line. I'm just going to count him when we get to the next one, so we're going to leave it at that. So let's make a little note. What did we just count? Well, I just counted and found that there were 14 people per strip. Per strip. And we also have 6 strips. So this is a conversion question again. We have 6 strips. We want to find the number of people. and we have 14 people per strip. That's our conversion factor. So let's actually set that up again real quick. What we have times what we want divided by what we have equals what we want. So I have the number of strips, that's 6. I want the number of people total, and I have my conversion factor. I know how many people are in each. I just want to fiddle with my position here for a moment. There we go. All right, so it's conversion factor. Let's type in our numbers, and I'll actually just write this in. All right, so we have 6 strips. Oops, let's try that again. So we have 6 strips. We want to have people, so I know I have 14 people. It's hard to write on my touch screen, so I'm going to use short forms here. Over what we have is strips, and I have 14 people per one strip here in my conversion factor, so 14 people every one strip. And that's going to equal some number of people. So let's go ahead and do our math. 6 times 14, so I'm going to switch to my calculator. 6 times 14 gives me 84. Divided by 1 is still 84. So that's going to give us 84 people. And we can type that out a little neater just to have our concluding statement. Therefore, we estimate there are 84 people present. And in this case, 84 is a pretty small number. We can actually count and see if we get the right number. So we're done estimating. We've demonstrated how to estimate. That's fine. But let's actually check and just see how good our answer was. So I'm going to keep counting and see how many people I get all together. So I'm going to switch to highlighter here. All right, so we counted 14 people here. Let's keep going just to compare. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85. All right, so we estimated there were 84 people. We actually counted 85, so our estimate was actually very close. We had very few small amount of error there, so our estimating technique was actually really good. So we were asked to estimate the number, and then we were asked to describe the strategy. I'm just going to describe that in words. So our strategy was to take the entire area we were looking at, cut it into equally sized strips, where each strip had an amount of people that was easily counted. I mean, I could have just cut this in half and had 2 strips, but that's a lot of people to count still. I want something much more reasonable. So cut it into strips that were reasonably easy to count. I counted how many people were in each strip, which gave me my conversion factor, and then I just did another conversion problem. 6 strips times 14 people per strip. Strips cancels out. I'm left with 84 people. And then compare with a classmate. We don't need to worry about that. All right, let's try estimating again. In this case, they've kind of made a lot more sections. Instead of long strips, we're looking at squares. So pick a square in the picture. How many people are in the square? All right, let's start. And you can hopefully see the squares here. There's quite a few. And I'll use my highlighter here again. Let's take a look at this square. How many people are in this square? Well, we can see that one dude takes up 4 squares. There's only part of a dude here. So I'm going to say there's like a quarter person in this square. Let's try another example real quick. Let's look down here. In this square, there's about half a person. The highlighter tries to interpret what I mean, so it's getting rid of that, but it's half. In this square, we have about half a person. And in this square, we have about half a person. It looks like if we just pick squares at random, a lot of them have about half a person in them. This only had a quarter, but I'm seeing half a person a lot more. So let's use that as our number. How many people are in a square? About half. How many squares are in the picture? Once again, we could just sit and count these directly, but we want to use a mathematical tool to make our life a little easier. And we're going to use the idea of area here. So how many squares make up this entire picture? Or what is the area of this? We're just going to do the length times the width. So how long is our picture? How many squares across? Let's take a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 times the width. So how many squares go the other way? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And let's switch to our calculator. 15 times 13 gives us 195 squares. All right, assuming that each square has the same number of people in it, how many people are in this picture? All right, we're going to do this just like we've done before. It's another conversion question. I want to go from number of squares to number of people. So I'm going to handwrite this kind of off to the side. So I have 195 squares. My conversion factor is my 1 over 2 here. I said that there was half a person per every square. So 0.5 people per 1 square. And let's multiply and calculate. 195 times 0.5. 195 times 0.5 gives us 97.5. We usually round down when we're estimating people. So I'm going to write my answer as 97 people. So we're off by a little bit. This is the same picture as last time. Remember, we estimated there was, well, let's double check. Last time we estimated 84 people, and we counted 85. In this case, we're off by a little bit. We're at 97. We're a little bit higher, but it's still pretty reasonable. This question I've kind of written over asks us to state one advantage of using this method of estimating the people in the picture. The nice thing is we don't have to count as high. We're just looking at a really small area. We're counting how many people are in each of those tiny squares, and then we're extrapolating. So it's less counting. Less and quicker counting. The disadvantage is that we were kind of zoomed in too much. It was already hard to decide how many people are in that square. Is it a quarter of a person? Is it half a person? If we look at some of these squares, there's no person in there. And so the disadvantage is that we were kind of too zoomed in. There was less than 1 person per square. So our estimate was less accurate. All right. Let's take a look at another example. May wants to build a rectangular patio in her backyard. The patio will be built in the center of 4 trees, which form a rectangle. Mai is using the square patio stones that measure 12 inches by 12 inches. Draw a sketch of the patio Mai wants to build. Calculate how many patio stones she would need, and estimate how many patio stones there are in the picture. So first of all, we already have a sketch here. And they say it wants to be 10 by 15, so we want 10 rows going this way, because each tile is a foot, and 15 going this way. So I'm not going to redo the sketch. How many patio stones is she going to need? This is the same as our previous question. We're just finding the area, how big, or how much of that surface is covered. Area is length times width. We know it's 10 feet long by 15 feet wide. Let's go to our calculator. 10 times 15 is 150. So we're going to need 150 square feet. They told us in the question that each patio stone is 1 square foot. So it means they're going to need 150 patio stones. Question C asks us to estimate how many patio stones there are in the picture and devise a strategy you could use to estimate the number of patio stones in the pile. We're going to treat this just like the picture on the previous page. I'm going to look at all my patio stones, and I'm going to divide it into sections and see how many are in each section. So let's take a look. I'm going to sketch, and I always start by making a line down the middle, and in this case I'll put a line at the ends. And then I just kind of look at it and think, what's a reasonable number of slices? We've already done 6. Let's try 8 this time. So let's see. I want 1, 2, 3. 1, 2, 3. So how many slices do we have? 1, 2, 3, 4, 5, 6, 7, 8. That looks pretty good. So let's write that on the side somewhere. We have 8 slices. And we want to know how many bricks per slice. Let's just choose this slice right here. Let's count 1, 2, 3, 4, 5, 6, and a bunch of little bits. So let's say like 7. So 7 bricks per slice. Once again, this is a conversion question. I have slices. I have the conversion factor of 7 bricks per slice, and the thing I want to find is the number of bricks. So let's set it up. I'll write it down here. So I'm going to start with 8 slices, multiply by my conversion factor, 7 bricks per 1 slice equals my number of bricks. Let's get our calculator. 8 times 7 divided by 1. So I have 8 times 7, which is 56, divided by 1 is still 56. And so we estimate that there are 56 bricks present. Now that does mean that she doesn't have enough bricks to complete her patio, but she has enough to get started. She needs 150. She has 56. So she has about a third of what she needs. And once again, this is a real thing you could do in real life. We had a pile of bricks that was laying there. We could take a picture, maybe a picture from above, kind of like the pictures of the crowd we've talked about. We could slice that into pieces, and we could estimate how many bricks we have without needing to hand bomb and hand count them all. We can just take a picture and do some calculations. The next couple pages are just extra practice for you involving estimating. It's up depending on where we are in class. If you have time, go ahead and try these, but I will not be taking these up together. If you have a specific question about how to answer this, or you have trouble with a question, please let me know. But otherwise, we're going to stop there because we've already covered our overall method of how do I estimate large numbers. Break it into chunks, figure out how many chunks we have, find our conversion factor, how many people or items is in each chunk, and then just multiply what we have times the conversion factor to give us what we want.